Hello students, Stride here again. Today we get notes for section 2.3, chemical properties. Then our key questions: when can chemical properties be observed? As a candle burns, its compounds combine with oxygen in the air and form water and carbon dioxide. Chemical property is any ability to produce a change in the composition of matter. Flammability and reactivity are two examples of chemical properties. Key point: chemical properties can be observed only when the substances in a sample of matter are changing into different substances, like in the example up here. We're getting totally new substances. A couple particular chemical properties are flammability and reactivity. Flammability, a material's ability to burn in the presence of oxygen. Reactivity, property that describes how readily a substance combines chemically with other substances, is called reactivity. In chemistry, we talk about substances being very reactive, low reactive, non-reactive, such things as these. Rust forms when oxygen binds with iron and water. Rust is a brittle, reddish-brown compound because iron is highly reactive. We do not choose iron to make jewelry or coins. So, very reactive. Not good for jewelry or coins. There we want unreactive things such as gold and silver. Nitrogen, very unreactive substance. In Japan, researchers have been putting nitrogen into steel tanks that hold seawater in ships. Nitrogen displaces the oxygen dissolved in water and prevents rusting. Another key question: what observations might indicate that a chemical change has occurred? And three common types of evidence for chemical change are a change in color, production of a gas, and the formation of a precipitate. There are others, such as heat being produced, light produced, and production or smell, production of a smell. Or maybe better, change in smell or production of an odor. Other ways we could phrase this. So, heat, light, odor being produced. Also, indications of a chemical change. So, recognizing chemical changes again. Here we show some bananas, and they go from green to yellow to more browns, getting brown spots. And this color change is caused by chemical changes taking place in the banana. Chemical change occurs when substances react and forms one or more new substances. Other things that we could observe about this banana changing: as it goes from the green to the yellow to the darker, it becomes much sweeter because it's producing sugars. It also goes from very rigid in the green state to kind of soft and mushy as it gets more into the brown state. People that cook with bananas, making something like banana bread, are going to use very, very ripe bananas, the ones that have a lot of brown with them, because that's where they are the sweetest. So, change in color, clue that a chemical change has produced at least one new substance. These are clues. It doesn't mean a change in color doesn't necessarily mean we do have a chemical change, but it's a clue that we do have it. You can have change in color, such as heating up a piece of iron. It's going to change colors. It's going to turn reddish orange, but we still have iron. It's not a chemical change. Some examples of some color changes in chemical change. Shiny silver bracelet exposed to air will darken. It's oxidizing. As a match burns, shrivels up and turns black. New copper roof and an old copper roof have different colors. So each of these we have a chemical change going on. Getting new substances. Here's a picture of the copper roof. New copper roof has a reddish color. As it's there for a while, it will get more of a greenish, brownish color. Here shown green. Making new compounds. Production of a gas, another indication of a chemical change. Mix vinegar and baking soda. Many of you probably have done this at some point. You can see bubbling, fizzing, foaming, indication of a chemical change. And use baking powder, a cake recipe, or in bread or anything else, yeast, baking powder. These cause carbon dioxide to be generated, causes the cake to rise, and you end up with little air pockets within the bread, makes it the bread or the cake. So, in most cooking, we're going to have some chemical change going on. Formation of a precipitate. Precipitate is a solid that forms during a chemical reaction. When an acid is added to milk, proteins in the milk undergo a chemical change, causes them to clump together, form a precipitate, we call cottage cheese. As milk becomes sour, because it's starting to produce more acids, it starts to form this cottage cheese substance. Key question: what is the difference between chemical and physical change? And our answer: when matter undergoes a chemical change, composition of the matter changes. When matter undergoes a physical change, the composition of matter remains the same. A simple way to phrase this: are different substances present after a change takes place? If not, the change is physical, not chemical. So all has to do with, do we get new substance? Does the composition change? And here's an example I mentioned earlier. Iron horseshoe is heated, it colors changes from gray to red, but the iron is still iron. So this is a physical change. So even if you observe a color change, a gas or precipitate, you cannot be sure that a chemical change has taken place. The more changes we see, the more certain we can be we have a chemical change. If we just see one change, we have to look very, very closely. And a few review questions. Which of these properties is a chemical property of sulfur? And that would be, it is flammable. To check and see if it's flammable, we must produce new substances if it is flammable. Yellow, brittle, soft, all examples of physical properties. Which of the following is not a common evidence for chemical change? So the three we listed were color change, gas produced in a precipitate form, so it must be a change of state. And a change of state can be an evidence of a chemical change also, such as when you cook an egg, you heat it up and it changes from a liquid to a solid. If it goes backwards of what you would expect, heating things up shouldn't make it a solid, shouldn't melt it or change it to gas, then you might have a chemical change going on. You can be certain a chemical change has occurred when new substances are formed. Any of these others can be indications of both chemical and physical changes. But we get that new substance, got a chemical change. And that's all for section 2.3. Till next time, stride here.